Ever wonder about the enigmatic nature of black holes? Are they simply cosmic devourers, or could they be something more? Today, we delve into the intriguing theory that black holes may function similarly to a spatial induction engine. Imagine, if you will, a black hole as a vibrating flat disk, akin to an audio speaker or microphone. If we consider the black hole to consist of alternating currents, it could potentially vibrate in a similar fashion. Now envision this concept in three separate functional parts, leveraging the Einstein-Rosen Bridge model and incorporating Faraday's principles for electromagnetic induction. Suddenly, the black hole begins to look a lot like a spatial induction engine. So, what exactly is a spatial induction engine? When we view the underlying relative force for the black hole as alternating current, we can explain the acceleration towards the core and the equivalent opposing force required to reach an event horizon. Using Faraday's electromagnetic induction principles, we can represent the intake and outflow of alternating current as gravity, modulated from the engine's core with a measure of impedance. To align with Faraday's principles, the functional parts of the black hole are theorized in terms of relative gravity. Operating like a waveguide, the amplitude is a property of the collector cavity, velocity a measure of the period of containment, and frequency is expressed like an alternating current. These three separate parts can be viewed as three conceptual states of transference induction that could behave like, or actually resemble, an electrical alternator's behavior. Firstly, in the spatial induction engine, all forces are absorbed within a collector cavity or vortex, much like the observed behavior of a black hole. Consistent with the nature of alternating current, a counterforce in superposition overcomes the inertia of forces it collects. Secondly, in the absorption of all forces, a normalized relative force is collected and contained as a manifold of spatial time, akin to an Einstein-Rosen bridge, and for a period of time with a range of infinite duration. Lastly, as a product of the sum and represented as a variance of state, relative force becomes an emission of a resonance. This is represented as a synchronistic event of a potential field strength with respect to the manifold. In conclusion, black holes may not be as enigmatic as they seem. By viewing them through the lens of a spatial induction engine, we begin to unravel their potential function and behavior. With forces absorbed within a collector cavity, a normalized relative force collected, and the emission of a resonance as a product, black holes might just be the cosmos's most fascinating spatial induction engine.